Hello guys, now let us see how to solve exact differential equations. Basically, what is an exact differential equation? You rearrange the differential equation in the pattern m dx plus n dy equal to 0 if m is partial derivative with respect to x of some function and at the same time n also happens to be partial derivative with respect to y of the same function, then such equation is called exact. The condition for exactness can be stated as m dx plus n dy equal to 0 is exact if and only if partial derivative of m with respect to y equals the partial derivative of n with respect to x. What is m? Coefficient of dx. What is n? Coefficient of dy. So derivative with respect to y of m and derivative with respect to x of n, if they are equal, the equation is exact and vice versa. So it is if and only if. So let us solve a few questions based on exactness. If any equation is given to you and you are asked to check whether it is exact or not, you have to go with this condition. So let's go. Our first question says check whether exact, and the equation is 3y cos x plus 4x e raised to x plus 2x square e raised to x bracket close dx plus in bracket 3 sin x plus 3 times dy equal to 0. So as I have stated, let us note what is m. Coefficient of dx is m and coefficient of dy is n. Let us find out their partial derivatives. Derivative of m with respect to y partially. So there is single term containing y. Coefficient of y is 3 cos x, derivative of y is 1. So this is the derivative 3 cos x. Now let us go with n. N is 3 sin x plus 3. If we differentiate this partially with respect to x, it becomes 3 cos x and both coincide. So the given equation is exact. Now how to solve exact? So solution of exact differential equation is given by integration m dx plus integration terms in n free from x. Those terms which do not contain x, only those terms are taken and are integrated with respect to y, and the sum is equal to constant. This is the solution. So let us go with this. So what we have done, integration m we have copied, m dx plus terms in n free from x. Only this term is free from x. Now let us try to simplify this. We are integrating this, but with respect to x means y is treated as a constant here. So 3y as it is. Integration of cos x becomes sin x. Now in this case you observe there is a product. So we have to go by parts. So for the time being, what we have done, from these two terms we have taken e raised to x common. Inside the bracket we are having 4x plus 2x square. So let me read it once again. It becomes 3y sin x plus integration bracket 4x plus 2x square bracket close into e raised to x dx plus. Let us go next. This is integration 3 dy. With respect to y we have to integrate. So this will be 3y and right side is constant. Now we have to apply our by parts. So which will be our first function? We apply LIATE rule. Exponential is always given last preference. So this is our second function. This is our first function. So let's go with this. first function as it is into integration of e raised to x is e raised to x minus whatever we have got here, this is written, and derivative of the first term. So derivative of 4x is 4 and that of 2x square is 4x. So what we are getting is, let us read it once again fresh, 3y sin x as it is plus 4x plus 2x square times e raised to x minus integration of e raised to x into 4 plus 4x dx plus 3y equal to constant. This bracket helps you in getting the by parts rule. So bracket is just given another color, different color. So let us again apply this product formula here. 3y sin x as it is, this particular term as it is, 4x plus 2x square times e raised to x. Now it comes to this product. Here again I have to apply by parts. So what you observe is, let us change ink again. And you can see this bracket is taking care of by parts. Okay. So again 3y sin x as it is, this 4x plus 2x square times e raised to x as it is, minus sign as it is, now in bracket. First term will be your algebraic term, so 4 plus 4x as it is, integration of e raised to x is e raised to x minus whatever we got here we write inside this integration sign, and derivative of the first term, that is 4 dx plus 3y as it is equal to constant. Now let us simplify this. 3y sin x as it is, we are multiplying in 4x e raised to x plus 2x square e raised to x. Let us open this bracket. So minus 4 times e raised to x minus 4x times e raised to x, minus of minus makes it plus, and this integration we are just completing. 4 as it is, integration of e raised to x is e raised to x plus 3y equal to c. And what we observe is 4 of the terms are getting cancelled. 4x e raised to x with plus sign once and minus sign once cancel each other. 4 e raised to x with minus sign and plus sign cancel each other. And we are left with 3y sin x plus 2x square e raised to x plus 3y equal to constant. This is our solution. Let us go for another question of the same kind. The question says, check for exactness and solve. This was 2x minus 2y square bracket complete dx plus bracket 12y square minus 4xy dy equal to 0. Now let us note down our n. M we are differentiating partially with respect to y, so it becomes minus 4y. N we are differentiating with respect to x, so derivative of 12y square is a 0 and derivative of minus 4xy will be minus 4y. So what we observe is both are matching, they are equal to the given equation is exact. Now the solution of the exact differential equation is given by this formula, integration m dx plus integration terms in and free from x with respect to y equal to constant c. Therefore what we get, integration of 2x minus 2y square bracket closed dx plus integration of 12y square dy equal to constant. So integration of x will be x square by 2, coefficient 2 will be as it is, minus integration of 2y square will be 2xy square, then that of 12y square it will be 12 times y cube by 3 and after simplification the answer is x square minus 2xy square plus 4y cube equal to constant. Let us deal with one more question of the same kind, but the question directly asks us to solve. In this case we are having question as 6xy square plus 2y bracket close dx plus 12x square y plus 6x plus 3 bracket close dy equal to 0. M is 6xy square plus 2y. N is 12x square y plus 6x plus 3. Differentiating M partially with respect to y, derivative will be 2 comes down as a coefficient, so 6 2s are 12, x as it is, y. Plus derivative of 2y is 2. In case of n, it will be 24xy plus 6. What we observe is the the partial derivatives do not match. Del m by del y is not equal to del n by del x, so the equation is not exact. Then what to do? If the equation is not exact, you try to find out some factor. If I multiply it by that factor, the equation will turn exact. Such factor we call as integrating factor. So what we are observing here, if I take the difference of these two, what do I get in hand? If I get the difference, so I find that if I divide by m to the difference, I'm getting this kind of scenario. Inside the bracket I'm having 12xy plus 4, and in the denominator I find 2y can be taken common. Inside I'm left with thrice xy plus 1. Now here also I find 4 is common. We can take 4 common. Inside we are left with 3xy plus 1 in the numerator also and in the denominator also. That gets cancelled, and ultimately the answer is 2 upon y. It is a function of y, so let us label this as some q of y. Then the integrating factor is given by e raised to integration q of y dy. So this will be e raised to integration 2 by y dy. So ultimately it becomes e raised to twice log y, and that is e raised to log of y square. E and log are reverse processes, inverse functions. They cancel each other's effect and answer is y square. Now multiplying by this integrating factor to our given equation, we get y square times this complete dx plus y square times this complete dy equal to 0. So what is m and what is n? Let us note. M is 6xy raised to 4 plus 2y cube, and n becomes 12x square y cube plus 6xy square plus 3y square. Now this equation has turned exact. If you want, you can go through, you can check it. And let us go for its solution. Solution is given by integration m dx plus integration of terms in n free from x dy equal to constant. So we are getting this to be bracket integration bracket 6x y raised to 4 plus 2y cube dx plus integration of 3y square dy equal to constant. And what will be the integration? Power of x is raised by 1, increased by 1, so 6x square divided by the same number 2 into y raised to 4 as it is, plus here there is no x, so the integration will be x times whatever you have. And here in this case 3y square is there, we added 1 and divided by the number, it becomes y cube equal to constant. So this is the solution of this differential equation. So hope this video was very helpful to you in solving exact differential equations. Bye then.